Guys. Thank you. Alright, today's lesson, the aim is for you to be able to do questions. Questions like the sheet that I gave you yesterday, where you're able to do sine of not pi and 6 anymore, but things like 5 pi and 6, 7 pi and 6, maybe things like 20 pi on 3. Okay, 20 pi on 3. And figure out how do you use the exact values that you have, okay, to figure out angles that you don't know, or distances that you don't know yet. And we're going to use that because the circle, really, there's only one revolution. Now, it doesn't matter how many revolutions you do, you end up at specific points. Your goal is to find out where those points are. Once you know those points, your aim is to get the angle from the exact values that you've been learning. Okay? So my goal today is going to try to teach you how to approach doing things like, so I'm going to show you how to do sine of pi and 6. Then we're going to do sine of 5 pi and 6. Okay, and then we'll move on to, like, let's say sine of, just up it up to, let's say 14 pi on 3, something like that. Okay, now let's do the first example. And I want you to think, remember, sine represents which coordinates again? Sine is your y, good. And then your cos is your x. Okay, so what we're going to focus on now, sine is the y value. So we're saying, what's the y value, or y coordinate, when the distance, or the angle distance is pi and 6? Now your job is to know what pi and 6 is as a degree, or as an angle. So what is the angle if the distance is pi and 6, or radians is pi and 6? What is the angle? Not a half? 30. The answer to it is half, but the angle, so what I'm saying here is pi and 6 looks like this. Pi and 6 is the distance on the outside, remember the circumference, so pi and 6 is the distance in radians, but we know that the angle that corresponds to that is 30 degrees. For those who forgot, pi is like 180 degrees, so 180 divided by 6 tells me what degrees it's in. Okay, so that's another way of thinking about it. So you got pi, which is 180 degrees, which is equivalent to 180 degrees, because pi is a distance of half, and that's 180 degrees. So 180 divided by 6 is 30 degrees, okay? What we're actually asking at this point is we're saying, what is the y value at this coordinate? At this coordinate, you've got an x and a y coordinate. We want to know sine of that angle, which means the height, okay, the height. And so really, we're just saying sine, which is the height of 30 degrees. Now I'm going to just label that triangle so you can see. This is what we want. We want that y value there. Okay, so I'm just going to draw this triangle. We want to find y. Y is that opposite side. It's called the opposite side. This is your angle, that's your opposite side. So opposite is your y value. Sine of 30 degrees will give you y. And Will just said to us that sine of 30 degrees, learning your exact value, sine of 30 degrees is equal to half. Okay, so what we've just known is at this point, that's equal to half. And it makes sense that at this y value, it's positive. Y values are positive because you look at the y-axis, y is positive. Okay, now that was easy because it was from 0 to 90 degrees. It's an angle that we know. We only know pi and 6, pi and 3, pi and 4, pi and 2. Those are the only ones we know. Okay, we don't know any other angles. So when we're dealing with 5, pi and 6, that's something that we don't know now. That's not something familiar with. But your goal now is to work with it so that you can get pi and 6, pi and 4, pi and 3, or pi and 2. It's one of those that you want to get. Okay, so how do I do it? I'll show you. 5 pi and 6. Now this requires you to understand that 5 over 6 of pi is not actually even equivalent to 1 pi. Think about it. 5 out of 6. You haven't even made one whole yet. You only got 5 out of the 6 pieces. So how many more pieces do I need to make one whole? How many more do I need? 5 out of 6. Add with what will make one whole? 1 out of 6. 5 out of 6 plus 1 out of 6 gives you 6 out of 6. 6 out of 6 is 1 whole. Okay, we're going back to grade 3 fractions here. Another way of thinking about it is 5 pi out of 6, I need to add another pi and 6 to get 1 whole. This is equivalent to sine of 6 pi on 6, which is sine of pi. Okay, 1 pi. But the problem is we don't have sine of pi. It's not sine of pi that we have. We've got sine of 5 pi and 6. So instead of sine of pi, okay, we actually want to rewrite this whole thing, and I'm going to rewrite it again. So you can see, I'm just going to rub this one off, and we're going to work it again. Instead of writing 5 pi and 6, why don't I write it as, I'm going to write it like this. Why don't I write it as 6 pi on 6, take away 1 pi and 6. Have I confused anyone there? Because we just said 5 pi and 6 is closest to 1 pi, which is here. That's 1. That's one piece. 5 and 6 is 1/6 less. Because I've got 6 pieces in total. I've only got 5 of them. And I'm missing another 1/6 to make 1 pi, right? So why don't I rewrite 5 pi and 6 as 6 over 6 take away 1 and 6. So 6 over 6 take away 1 and 6 is 5 and 6. But why did I rewrite it like this? Why was my goal to rewrite like this? Because I now know where I am in the circle. See, now I know I'm at pi, subtract pi and 6. Because pi take away pi and 6 is 5 pi and 6. And this is nice because where's pi? Pi's right here. I know pi is right there. That's what I know. I only know 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. These are the only ones I know. So when I rearrange to write 5 pi and 6, I'm writing it as 1 pi. So it's starting here. And I'm saying subtract 1 pi and 6. I know it has to be here somewhere. I know it's in this region. So now that you know which region's it in, it's like this. This is what I'm drawing. I'm actually drawing out like this, and I'm saying lose pi and 6, and we know that the angle that to make pi and 6 was 30 degrees. So if this is what 5 pi and 6 is, 5 pi and 6 is starting from here. I'm going all the way here. That's 5 pi on 6. With an extra pi and 6, I make 1 whole. So instead of working 5 pi and 6, because I didn't know how to work 5 pi and 6, I do know how to do pi and 6. Because that was within our exact values. I said, you want to work with pi and 6, pi and 3, pi and 4, or pi and 2. In the equation that I read so far, you have a pi and 6. That's something you can work with. So now, what are you looking for? You're looking for sine, which is at this coordinate. You're asking, what's the height at this coordinate? And the nice thing here is you have another triangle, which I'll highlight, and I want you to see that this triangle is actually the same triangle as the one we just did before. So these two triangles are the same. 30 degrees, 30 degrees. They're in the same unit circle. Radius 1, radius 1. So if this is y, and you knew this was half, well then this length here has to also be half. So this must be half here too. So the coordinates here, if I asked you for the y coordinates, you're just looking for the height, which you know it has to be half. Okay, so the answer to what is sine of 5 pi on 6, the answer is, I know looking at the diagram here, this has to be half. Because I know this right here is equivalent to sine of pi and 6. Which we already did. We already know how to find sine of pi and 6. Sine of pi and 6 just meant y values, it was 30 degrees. Y values, it was 30 degrees. I know this is not 30 degrees. I know it was 150. But we're not trying to find 150. We're like, let's make it easier for ourselves. Why don't we change it to 30? Because we want to keep it in the 90-degree angle. Okay, anything less than 90 is something we know. We don't want to work with angles that are above that. How does that feel? So the hardest part here is working with your fractions and trying to convert the angles to something that you know where you are in the circle. That's the goal. Okay, so I'll make another one. So you know the one I said before? I said sine of, let's do it in red. Sine of 14 pi on 3. Okay? Now 14 pi and 3, see that's something I don't know. So the only angles I knew was pi and 6, pi and 3, pi and 4, pi and 2. I don't know 14 pi and 3. But what I do want to do is I want to rewrite this fraction to something I know where I can use pi and 3, pi and 2, pi and 4, or pi and 6. Okay? Now another way of writing 14 on 3. 14 on 3, I know 14 on 3, I can rewrite this as 15 pi on 3. Why did I choose 15 pi on 3? What's 15 pi on 3?
5.
It's 5. Yeah. And I know where 5 pi is. Any whole pi's I know. Now 15 pi on 3, how do I get down to 14? I'd have to subtract it by 1 pi on 3. See what I'm doing there? I'm saying instead of doing sine of 14 pi on 3, why don't I rewrite that fraction as 15 on 3, because that makes it 5. 5 pi, I know what that is. This is 0, 1, 2, 3, 4, 5. All the odd pi's are right here, and all the even pi's are here. So as soon as I see 5 pi, I know I'm starting right here. And what am I doing? I'm saying subtract. Subtract means I'm losing a certain amount. Okay, so I'll lose a certain amount. If I added, I'll be going down. Okay, so I'm losing, and this is something I know. This is nice. Pi 3 is an angle I know. Now, if I didn't do 15 pi 3, this makes it more difficult. You see, if I didn't do 15, and I went down. So let's say I did sine of 12 pi on 3. See, 12 pi on 3, I know. It's 4 pi. But then I have to add 2 pi on 3. That's a problem. Why? Because even though I know where 4 pi is here, I don't know how to work out 2 pi on 3. The only angles you had were pi and 6, pi and 3, pi and 4, pi and 2. This is why I like this one. This one was more preferable because you learn the exact values. Anything to do with pi and 3, pi and 2, pi and 4, pi and 6. Those are the ones you want. So this is more preferable. Okay, so now if I ignore the second line, it's not 12 pi and 3 because it doesn't seem to help with 2 pi and 3. I don't know how to do the 2 pi and 3. I know how to do pi and 3. Now let's look at where I am in the circle. So I'm going to draw the circle again. I'm going to erase this section here. So let's have a look. Let's look at the line that I just described. I said 5 pi, so I'm going to do it again here. This is sine of 5 pi minus pi on 3. 5 pi is right here. All the odd pi's are here. So this is 5 pi. I'm losing pi and 3. So I'm losing, that means it's going to go this way now. I'm going backwards. I'm losing pi and 3. But I know pi and 3 has a degree. What should this angle be to make a pi and 3? 60 degrees. Very good. So it has to be 60 degrees. Now if that's 60 degrees, now I've got a triangle. That's great. Because that triangle there is exactly the same triangle as if I did actually have 60 degrees. It's exactly the same. Now if I'm asking for sine, I'm just looking for the height. And that's when you use the exact values. Now you know the height here at this coordinate, the y values have to be positive. Okay? And so sine of 60 degrees or sine of pi and 3, we know that sine of 60 degrees has to be the exact values. What side of 60 degrees? Root 3 and 2. Drop down the ring finger. Count the number of sine fingers. You got 3. Square root the number of fingers divided by 2. Root 3 and 2. So I know the answer to this one now is root 3 on 2. And it has to be positive. Because the y values at this point is positive. Those are y values that are positive. Are we feeling a bit better? So the hardest part of this exercise is changing it to something that you know. That's the hardest part. So you're going to work with your fractions here. Okay? I'll do a few more. Here we go. And then I'm going to get you to think about it too. So let's do this example. Whoops. This one. So even before you think about cos and sine, don't worry about the cos and sine yet. Work with the fractions first. 5 pi and 4. Okay, your goal is to break it apart and figure out what would I rewrite 5 on 4. So 5 on 4, how would you rewrite this? Someone tell me. I want to rewrite this. How am I going to rewrite this? What do I rewrite it as? Yep, we can rewrite it as 4 pi on 4, which makes it 1 whole. Now 4 pi on 4, how many more do I need to make 5? 1. So I can say 4 pi on 4 plus 1 pi on 4 would be the same, which this is nice because this tells me it's pi, 1 pi plus pi and 4. This is nice because now on the circle, I can figure out where I am. Pi. Pi's all the way here. That's where I'm starting. I'm adding, so I'm going further down. Going furthermore, I'm adding an extra piece. And how much am I adding? Pi and 4. That happens to be an angle I know. Pi and 6, pi and 3, pi and 4, pi and 2. Those are the ones I only know. Not 2 pi and 4, not 2 pi and 3. It has to be pi and 4, pi and 6, pi and 2, pi and 3. If it's one of those, we can work with this. So now draw out my triangle again. I'm like, okay, I'm starting at pi. I'm adding an amount. I'm adding an amount. And added pi on 4. So this is my triangle. Whoops. This is my triangle. Oh. This is my triangle. So here we go. That's my triangle there. I know the angle to make pi and 4 has to be, what angle is this? Pi and 4 is equivalent to 45 degrees. Because it's 45 degrees, and I'm now asking for, what's the question? I'm asking for cos. At this point, I'm looking for cos. Cos is the x values. So I'm looking for this length. Cos at this point. So what's the x value? Cos of 45 degrees. So go to your exact values. What's cos of 45 degrees? Good. It is 1 on root 2. But what do you have to be careful of? At this point here, what's my x coordinate? What's my x coordinate at this point? Is it negative or positive? Negative. So at this point here, yes, you're right. This is root 2 on 2 or 1 on root 2. Okay, 1 on root 2 or root 2 on 2. Yes, the length is true. But remember, that is a negative coordinate. So you have to write your answer as negative 1 on root 2. Okay, because we're talking about coordinates at the moment. How's that feel? Let's try another one. Sine 11 pi on 6. So your goal is to make it a whole number, find out where you are in the circle, and then subtract or add. That's your goal. Okay, so let's go. Sine, instead of 11 pi on 6, what can I rewrite it as? Let's work with this one, 11 pi on 6. Which one would you work with now? 12 pi on 6. Good. 12 pi on 6 gives you 2 pi. Okay, so if I have 12 pi on 6, how do I get to 11? Minus 1. So minus 1 pi on 6. And this is nice because pi on 6 is something I know. So rewriting this is sine of 2 pi minus pi on 6. See, now if I work with a unit circle, let's go with a unit circle again. Let's go. I'm going to rub it all off and I'm going to say, all right, where is 2 pi? 2 pi is right over here. Minus. Think about it. Every time you add, you're going anti-clockwise. So if you're minusing, you're losing a chunk. You're going clockwise. Okay, so you're losing a chunk. So that means you are sitting now here. That's where you're sitting at. You know that you lost pi on 6. Pi on 6 is 30 degrees. Essentially, you are trying to find sine. Sine is the y values. Now looking at this point, what's my y values here? Is it negative or positive? Negative. Okay, it's below the x-axis is negative, and all you have to know is the length, which you know your exact values. Sine of 30 degrees. Okay, or sine of pi on 6. What's sine of 30 degrees? What's sine of 30 degrees? Good. Sine of pi on 6, we know the answer needs to be negative half, because at this point the coordinate is obviously a negative y value. That is the hardest part of your basics. Okay, if you understood what I was trying to say, or at least you're getting the gist of it, that's the hardest part. Okay, and if you understand how to plot or find where you are in the circle, that's the biggest battle. That's like half the course on circle functions. Because remember, what's the hardest in every chapter? Algebra. The sketching is not hard. The sketching you would have learned through transformations, up, down, left, right. You'll learn that very quickly. The hardest part of every chapter with exponentials, logs, quadratics being year 9, year 10, year 11. The hardest is factorize. Same thing with circular functions. What's your hardest one? Solving. Your goal is to eventually be able to solve for the x-axis intercept. So without being able to know where you are in the circle, you can't solve it. So if you can learn this, exercise F, this is 14F, learning to understand that you're just finding the x or y values, that's the key. Okay, so learn to rearrange how to do 11 pi on 6, because you only needed the 5 angles. Pi on 6, pi on 3, pi on 4, pi on 2, and 0, and that's it. Those are the only angles you needed, and you'll be able to rearrange them all to get your exact values. Okay, so that's the goal for today. Okay, so 14F, I want you to practice doing this question or this exercise here, or the sheet that I gave you. At the end of this session, I'm going to give you the solutions to the sheet I gave to you yesterday, so that you can practice doing these kind of questions. Okay, the better that you can do this, the easier it is to then do solutions for x-axis intercept. So I want you to eventually be able to do times 2 times 3. You should be able to think in your head. 2 pi and 3 is in the second quadrant, and therefore sine is positive, so I know sine of pi and 3, which is root 3 and 2. So I know the answer here is root 3 and 2. It has to be that sort of quick. It's like your times tables. So you got to learn your exact values, learn the symmetry properties. That's what we're going to do. Okay? We'll leave this here. I'm going to get you to start on exercise 49, question 2. Okay? Don't worry about question 1. Start on question 2. This is your bread and butter of the course. Learn that, and then you'll find everything else much easier to do. Okay? I'm going to stop the video there. And we're going to go through solutions for this one too.